Hello, my name's David Allinson and thank you for inviting me to this workshop to talk about the technical evaluation of SMETER technologies or test project. The project was funded by the UK Department for Business, Energy and Industrial Strategy. The project is a collaboration between Loughborough University, Halton Housing, Leeds Beckett University and University College London. And the aim of the project was to evaluate the performance of SMETER technologies, and these technologies were being developed under separate BEIS funding. SMETER stands for Smart Meter Enabled Thermal Efficiency Rating, and SMETERs calculate the heat transfer coefficient, or the HTC, of homes while those homes are being lived in. There were 8 different SMETERs in the main trial of this project. 2 of them used only gas and electricity smart meter data, and the other 6 included some sort of product that was installed in the home. In some cases this was just sensors, and in other cases it was a heating controller. The field trial comprised of 30 homes, and each one of them was carefully surveyed, and we carried out a co-heating test and a blower door test to measure the HTC while the home was empty. We then installed monitoring equipment in every home, and this provided with us with an independent data stream: gas and electricity meter data, temperature and relative humidity. We then installed SMETERs, and each SMETER was allocated to 10 of the 30 homes, so that there were 2 or 3 SMETER products in each home. And then finally a household moved into the home, and then the trial in that case started. After the first winter, the participating organisations reported the HTC of each of the homes. Sometimes this was using data collected by their own SMETER, and sometimes using the data that we provided. And all of the results were compared with the measured HTC. It's important to say that this was a blind trial, so the participating organisations did not know the measured HTC values. And the results that I'm presenting here are from an intermediate stage, but I think it's fair to say that the final results are not going to be wildly different. This is an example of the results from one of the 30 homes. We're not revealing the identity of each of the SMETERs at this stage, but you can see from the first bar that the measured HTC was about 150 watts per Kelvin, and that it has a 95% confidence interval somewhere from 133 watts per Kelvin to 178 watts per Kelvin. And then each of the 8 SMETERs gives a slightly different HTC, and each result includes its own self-reported estimate of the confidence interval. There were 2 main ways in which we assessed the accuracy. Firstly, we simply looked to see if the confidence intervals overlapped. And then secondly, we ignored the confidence intervals and we just calculated the difference between each of the calculated HTCs from a SMETER and the measured HTC. And I'll explain this a little bit further as I give the results. So this is an example of the first type of evaluation. Here, SMETER 1 and SMETER 2 have confidence intervals that overlap with the measured co-heating HTC. And so in each case this was deemed to be a successful calculation. However, you can see that SMETER 3 falls a little bit short, and in this case it would have been deemed unsuccessful. This chart shows how many of the reported results were successful based on these overlapping confidence intervals, and you can see that the results varied, but one SMETER was successful in all cases and most of them did very, very well. This chart shows the averages of the reported confidence intervals for all 30 of the homes for each SMETER. This and the previous chart were in rank order, but the rank order is different in each case. And you can see that these averages range from, this SMETER had a uncertainty of plus or minus 13%, and this one plus or minus 45%, with the others falling in between. Of course, confidence intervals are not everything, and this chart shows the analysis of the difference between the measured and calculated HTC for each home. Each of these box whiskers represents one SMETER, and you can see that for this first SMETER on the left, the difference between the calculated and measured ranges from more than minus 100 watts per Kelvin up to over 75 watts per Kelvin. So quite a big range. The bar in the middle is the median difference, and the cross here shows the mean of the differences. So you can see in this case there is a bias towards a lower calculated HTC on average. You can also see that this SMETER, for example, on the far right, has very little bias on average and a smaller range as well. So we could say that it was more accurate for these cases. So we used these differences for each SMETER to calculate two standard metrics. The first one was the average difference, or the normalized mean bias error, and this is a measure of the trueness. Ideally it would be 0 or as close to 0 as possible. The second one was the range of the difference, and here we used the coefficient of variation of root mean square error, and this is a comparative measure of the precision of the calculated HTC, and here the lower the number the better. So this chart shows the normalized mean bias error and the coefficient of variation of root mean square error for each of the 8 SMETERs across the 30 homes. The best SMETERs have a normalized mean bias error very close to 0, and the coefficient of variation of root mean square error is less than around 15%. The project isn't yet entirely completed, and there are some results that will follow soon. First of all, there will be updated SMETER calculated HTCs that follow from a further winter of monitoring. We monitored them over the last winter as well, and some of the participating organisations will update their results. Secondly, we are comparing these results with the HTC that would come from using RDSAP in a commercial EPC assessment. So the question here is, how much better than RDSAP are the SMETERs? There were, of course, some limitations of the field trial. Firstly, to be fair to all of the participants, we needed to use very similar houses, and so they are all of EPC band C or D. They've all got gas boilers, and there were no flats or mid terraces to reduce the influences of party wall heat losses. To summarise the findings, all 8 SMETERs were able to predict the HTC of the homes in this field trial. The self-declared uncertainty ranged from plus or minus 13% to plus or minus 45%, and the trueness and the precision achieved using the metrics I described also varied between SMETERs from the best to the poorest performing. Further work is needed now to extend these findings to more homes and heating systems, but I think it's fair to say that the trial was a success, and SMETER technologies have the potential to play an important role. So that's all I want to say for now. Thank you very much for listening to this presentation, and I'd be very happy to answer any questions.